else is doing a good job.
I don't know. I know the package. Okay. Probably keep going.
Okay, cool. So yeah. So how many of you again have experience with Python? So I'll ask the question slightly different. Okay.
How many have experience with Python?
Okay.
Okay.
How many of you have heard of something called it used to be called an IPython notebook. Now they're called Jupyter notebooks. Okay.
A small part.
So this workshop, the way it's going to work from here on out pretty much is we're going to be doing things within what's called a Python or a Jupyter notebook. And so let's figure out what the heck a Jupyter notebook is and why we would want to use that. So we're going to go back to the command line, and you want to make sure that you're in your Unidata Workshop environment. Ryan has a lot of environments, and sure enough, I did a conda env list, and I can see that, yes, I'm in the Unidata Workshop environment.
Well, most of you, at least if you're at Bash, at the beginning of your prompt, it'll add the workshop or the environment name that's active.
Mine doesn't do that. Okay, so and the next step we want to do is make sure we're within the Git repository we checked out, the Unidata Python Workshop. So like Ryan checked it out under his home directory, and it has some stuff in it. The contents of the directory should look like that. Everybody there? Okay, now what we're going to do is we're going to start the Jupyter notebook. So to do that, we type Jupyter. Now it's not like the planet. It's Jupyter space notebook. And then hit enter. Now on some of your machines, it may bring up your web browser and take you to something. On others, it may not. So if it doesn't, you can open your browser. Looks like Ryan, no. He had something up there, but so we'll do, you want to go to http://localhost 8888, and you should see what looks like a listing of the files in that directory. Anybody not seeing this?
You probably won't have the blue barrel on the top,
Yeah.
though.
Yours won't have the color, it'll be different colors.
Yeah, Ryan's a special snowflake.
Yes, I am.
Okay, so from here we're going to go. These little folder icons, of course, are folders, and then the file icons are files in our repository. We're going to go into notebooks and Jupyter examples. And in here we see there's a series of files that end with .ipynb. Those are our notebooks. And if you click on, say, 0 getting started, that's going to bring up a Jupyter notebook. So the main thing with these notebooks is they're made up of a series of cells. And so as you can see on the screen, it's kind of highlighted on the left edge, I guess audience right edge. So whatever cell is highlighted is the one you're currently on. And you can use your arrow key to go up and down.
Yeah.
And so each kind of cell that's in the notebook, you have a choice of what it can contain. There's code. You can put Python code in a cell and say this is a code cell. That's the default. You can do something called Markdown. which is what allows us to have lists and nested lists, and some highlighting and formatting of the text, or you can have a raw cell. We're going to just deal with markdown and code cells. Now, if like I said, you can navigate these cells using the up and down arrow keys. If I go to the next cell, this talks about the different modes. So if you have a cell highlighted and you hit enter, you go into edit mode. And so this is what markdown looks like. Who's not familiar with markdown? Okay, markdown's used lots of places, which means if you learn it here for your notebooks, it'll apply other places as well. The design goal behind markdown was to be able to make bulleted lists and make words bold and change the font using different markups, so like the 2 pound signs, but keep the text itself to where you could look at it without it being rendered and shown nice and pretty. You could look at it and figure out what's going on. So the asterisks already sort of look like it's a list. The number two, and whatnot. So it's not like HTML where you're marking up the text and you've got all these little braced tags around it flying all over the place, and it's hard to read on its own. So the goal with markdown is you should be able to read the plain text without gouging your eyeballs out. And then if it just so happens that you're in something that knows markdown and understands how to make it pretty, it'll make it look pretty. And so to do that with a markdown cell, you would execute the cell. Now, in order to execute the cell, you can hold Shift and press Enter. And what that will do is actually execute the cell and go to the next one. Okay, so you should be now highlighted on number 3. So if you hit Enter again, that's going to take you into edit mode. And if you hit exit, that'll take you back, or escape, sorry. If you hit the escape button, that will take you back to where you can navigate with the arrow keys. But so why, quick question from what I just said, why does this not look pretty like the other cells? Why does it look like just markup or markdown? I haven't executed it. So Shift Enter will run the cell and go below. If you do a Control Enter, it'll run the cell and keep you there. So Shift Enter, Control Enter, either one is going to execute that. And if it's markdown, the notebook will say, I will render this as pretty HTML for you. If it's Python code, it will take that code and send it to the Python interpreter, run it, and display the results for you. So in this environment, we can actually have nice, pretty text, but also code that's embedded that's executable. Now, to focus on the pretty text, here at the bottom, if you go to the bottom of this notebook, you'll see there's a link to a Jupyter Notebook cheat sheet. You don't have to click that. I'll click it. And here's a whole bunch of cheat sheet-like things. I think there are better Jupyter Notebook cheat sheets out there. But
well, if you go to, so at the top, you see the menu bar with the file edit. Under Help, you see keyboard shortcuts. So they list a whole bunch of shortcuts to make things easier.
now, to be honest, for me, I use the File, Edit, View, Insert, Cell, Kernel, Widgets, Help buttons at the top of the toolbar and Shift Enter. That's my thing. It's not like VI where you absolutely need to know all these crazy combinations to even get out of the thing, right? What's the joke? I tried VI a month ago and it's still running on my machine.
But the default out of the box keyboard shortcuts, a lot of them do map to VI commands. So if you're familiar with VI, a lot of the same navigation and like deleting a cell apply.
Okay, so back to our getting started notebook. At the bottom, very bottom, there's a link that says next. Markdown. So you can actually link these notebooks together using links. And so you could have a work progression as you go through different notebooks. And what this is, it's a list of various ways of doing things in Markdown. And so we're not going to go through all of this, but for example, headers. If you do one hash sign or 2 or 3 or 4 or 5 or 6, you get basically the different header elements of HTML that get rendered. So you want to control the size of headers. That's how you would do it. If you want to format text with, say, you want it to be italic or bold italic or monospace, you would do that with various numbers of asterisks or backticks. And then it shows you what that actually looks like below. So this is the Markdown. That's what it looks like. And the next cell down is what it actually is. You can make lists. You can make them unordered, ordered. You can nest them just by the number of spaces you have. And that's what it gets rendered to. You can quote stuff if you would like. And so much like a Gmail conversation, you've got these little carrots, a right caret. And the way that gets rendered is the text is offset. It's got a horizontal or a vertical rule line by it. Makes it look nice. You can also do code. And so if you indent the text by 4 spaces, it's going to interpret that as a code. Or if you surround your code with backticks, it'll interpret it as code. And after the first set of these backticks, these 3 backticks, if you put what kind of code it is, it'll actually do syntax highlighting. So regular old plain code here on top, and now we can do the syntax highlighting if we tell it a little bit more about what it is. So it could be Java code, it could be XML, it could be R, and it'll know how to highlight that syntax. So that's kind of cool. And then you can also make links and anchors so that you could jump to sections in your notebook just from making an anchor. And that's kind of how it looks, how you would do that. And then while it's not official Markdown syntax, you can do tables. There are several flavors of Markdown. At the top of this page, it takes you to the developers, the guy who made Markdown. It takes you to his webpage, and it says, this is Markdown. And not having tables is kind of lame, but that's how it works. But in Jupyter Notebooks, as well as some other things, I do believe GitHub will allow you to do a table like this. So there's ways of justifying how the table elements are laid out. You could center, left, or right. You can highlight. You can make things header rows so that they're a little bold, a little easier to read. What you can't do with this table syntax is decide if the whole table is going to go to the left of your screen, the right of your screen, span the screen. So it's somewhat limited. But if you want to do a basic table, you can certainly do that in Markdown. But one of the cool things about Markdown is if you need to use HTML to do something, you can. So within a Markdown document, you could include some HTML elements to get the job done, and it'll still render it and work. So this is just some Markdown here, Markdown, and now we've added an H3 tag. We've got a paragraph tag, and here we've got a reference to this programming in C book or tutorial. And so that's how it renders. And so the HTML that knows about doing references, so this little one up here, that's done in HTML, and then it links down here, and you can see what that reference is for. So maybe at this point you could say, I could almost use notebooks to maybe make lecture notes, and it wouldn't be so terrible. But imagine if you could do code in here as well next to your lecture notes. There's also, and we're not going to show it, there's a presentation mode for these notebooks. So you could actually do presentations in a Jupyter notebook. So you could have a notebook, or you could have a presentation like a slideshow with cells that are executable pieces of code. And you could change stuff up at the top, up at the front of your class and see how things move around. So just as an example, I'm a boundary layer guy, sorry. Let's say you were doing the log profile for wind and you wanted to change, what happens if we change von Kaufman's constant? And it's not 0.4 or 0.39, no flame wars, no flame wars. Then you could set up there at the front of your class, show a log profile and say, well, what if we change, the friction velocity? How's that going to make my profile change? And so you go into the code cell, you change a number, you execute it. All of a sudden a figure changes and now you see the difference by using a different U star. It's kind of cool. And Markdown is pretty easy to learn. So there are lots of cheat sheets and tutorials out there. But this is one reason we're going to teach the rest of this class using notebooks, because you can do things like this. So at the bottom, again, we have another link. It says Next Notebook Features. And these are the features of the notebook itself. Not all the features, but some really nice ones. So when you're using the Jupyter Notebook for writing Python code, you can get nice errors. Now, errors suck. There's no such thing as a nice error. But there's prettifying an error to make it easier to understand. And that's something that we can get out of using a notebook. So if we go in under nice errors and we click on this the cell so that we can activate it, or if you remember your shortcuts, if you just highlight that cell and press enter, it'll take you into edit mode. So I can edit the text in the cell. And if you notice off to the left of it, there's in, and then in square brackets, it's empty. But this is your visual signal or visual clue that I'm dealing with a code cell. I could actually execute code in this. Now, if I delete the pound sign, that's in Python, that's the comment symbol. So right now it's just a comment. So if I hit shift and return or shift enter, it doesn't do anything. I just executed a comment line. So that's kind of lame. Now, if I go in and remove that, you see the number 1 turned green, the plus sign turned purple. So we're getting syntax highlighting in the cell. It's kind of nice. And if I execute this, what do you think is going to happen? It's going to go, whoa, whoa, cowboy. So that's what a Python error looks like. And so here we get an idea of, in red text, name error. So name error, and it's pointing here to the line of code where the error happened. So I know here, this 1 plus foos, there's a problem. And then it tells me error foos is not defined. And so I go, oh man, I didn't define that variable called foos. Junk. So if I wanted to, I could go in here and say, okay, foos equals 3. Re-execute that cell. And it's going to tell me the output's 4. So I just did 1 plus 4. Hooray. And so when you're debugging your programs, being able to see those nice error messages pretty clearly on the screen really helps figure out what the heck's going on. Now sometimes, especially for those who are learning Python, you might have a question about a function. Open, what the heck is open? Open what? Open the door? I don't know. And so inside of a notebook, you can do a question mark after a command. And when you execute that, it's going to bring up the documentation for that command. And so here it tells us what open is. It says open a file and return a stream. It's going to give you an error if there's a failure associated with it. And then it goes down and tells you all the different options you can use. You can give it these different characters for telling how you want to open the file. Is it read only? Do I want to open it in binary mode, which you may want to do if you're trying to read in binary data? Yeah, there's all kinds of things that open will do. And so that's neat. There's a little X on the screen that popped up for the documentation. You can just close it. My most used and favorite feature is tab completion. So I'm in this cell about tab completion, and there's an O with a comment sign before it. So if I just delete that and I say O, and I hit tab, give me a list of possibilities here. And so let's say I'm coming from a programming language that's not Python, and I'm looking for a function that opens a file. I can do OP and tab, and it'll complete it for me and say, oh, I think you're looking for open. And then I can go, well, maybe I'm looking for open, add the question mark and return, read the doc string and go, yes, that's what I want. That's the thing I'm looking for. So when you're typing, you can hit tab. It'll try to complete stuff or give you a list of options to choose from. You can also run shell commands by using the exclamation point. So exclamation point ls, if I execute that, it's going to give me a directory listing of where this notebook currently lives. So we're in number 2 features. That's the notebook we're in. We see there's 3 and 4 and 5 and exercises. Okay, cool. That's not bad. So you can do shell commands from there. How many of you have used netcdf before? So okay, cool. We're going to cover netcdf after lunch, but if you've used netcdf, you're probably familiar with the ncdump command. So imagine using ncdump to look at the contents of your netcdf file from within the notebook. Now, you can do that with Python and get all that information quite easily. We're going to do that after lunch. But in theory, you could do an ncdump from within the notebook. There's also the ability to get remote information. So if we want to display an image from a URL, or if we've got a URL to a scalable vector graphic and we want to set how big it is, we can do that as well. Or if you just need to add that cat video to your lecture, or in this case, super hurricane and typhoon video from YouTube, you can certainly do that. So you can embed remote stuff, remote content into your notebook and tie together videos from YouTube or images from a news outlet with the analysis you're doing and use Markdown to make it all look pretty. Number 7's a little tricky and don't really use it much. But what it allows you to do, I want to click this link. You don't have to, but matplotlib, they have, oh, that link's actually going to download a file on Ryan's computer. Can I just say, no, I can't. So what it is it's linking to a Python script on matplotlib's website. Matplotlib is a plotting library for Python. We're going to use it like crazy. But this is just a demo script that's on their website. So I could go out, download it, and run it. Or I could use this thing called LoadPy. And so what LoadPy will do is it will go out to this website, to the resource, which is a Python script. It will grab the contents of that Python script and put it in my cell. Now, it's not going to auto-execute it. It's just going to grab the text from that script and replace what's in that cell with it. So if I execute this LoadPy cell, it's going to give me a comment that this was loaded from this URL, and here's what the code is that was in that Python script out there. Now I've got that code locally on my machine, and if I so choose, I can run that, and now I've got a pretty 3D image of some points in 3D space with a line snaking through it. So this code isn't actually running on Matplotlib's website. It's just grab the contents of that file, the text stuff, put that in the cell, and then I chose to execute that. And now I've got the demo working in my notebook.
And that works also for local files too. So if you have a script somewhere you've saved, you can use LoadPy to bring that into a cell so you can play with it some more without having to go and manually open the file and copy and paste the content. Get in there, you can just use load to load the local script as well.
So next, we got a taste of it. This is the plotting examples. You can execute Python code that will make plots, and they will show up in your notebook. And so now we could have text, we could have code that does analysis, and then we can visualize the results all in the same environment. You could almost put a paper together this way if journals would accept such a thing.
So you don't have to load Matplotlib? Here it
First,
says inline. What does that mean?
So this is these things with percents in front of them are called magic or magic functions. So this is
specific to the notebook.
right.
Okay.
And so this handles that. And then here, this example is importing plot stuff from PyLab.
It's Matplotlib. It's just it's Matplotlib's MATLAB interface.
Yeah.
Which is one big thing that makes it easy to get a MATLAB-like environment.
So when we do our plotting later, we're not going to use PyLab stuff. We're actually going to do it a bit differently. But this is just kind of a demo showing you what these notebooks can do. Again, if you were given this code and you ran it and you got the image and you were looking through trying to figure out what does this do, and you saw something called linspace, what the heck is linspace? You could always do the question mark stuff. Now this time the question mark's coming first. So really you could type in a function and do a question mark, or a question mark and then the function. The result's going to be the same. It's going to give you the doc string for that. And so this explains what the heck linspace is. You could run some experiments. We could do a figure and see what happens if we reduce one of these three RR0 parameters. We could also change some other parameters and then look at how the graphs differ. So if I've got, R equal capital R10, lowercase r 0.4, O12, I get this result. If I keep those the same, but instead of going from minus pi to pi by 30 steps, I said let's go from minus pi over 2 to pi by 3,000 steps. How does that graph look now? And then if I change it so that it's just slightly different, I want to see how it looks. Well, now we got a new figure and yeehaw. But in this case, we're simply just changing parameters and generating the same graph over and over again and comparing.
We'll cover all that array stuff in plotting in more detail right after lunch.
Again, you don't have to understand any of the code in here yet. No big deal. So wouldn't it be nice if we could actually, instead of change some parameters, image, change some parameters, image, if we could have an image and then a little slider bar I could drag around and say, I'm changing the parameters now, and the image updates as you do that. That would be much better. And so the next notebook, which is on interactive widgets, covers that. So within the notebook environment, you could have these interactive widgets. And so I'm just going to run down through here. Basically, I'm defining different functions in this block. So if you're a boundary layer person, you can have the log law, you can have some Mononobokov stuff, Mononobokov functions. And then this this piece of code just generates up what parameters can change and what the range is on those parameters, some very basic information. And now I can have a drop-down list of the functions I want, and I can change parameters. I'll slide it around and see how in this case, the graph responds. So change the number of points. We can go up to 30 points in the graph or what have you. And so these notebooks, you can actually do some really cool stuff with these widgets. I mean, if only there was a way to maybe grab some data, load it onto a map, do a bit of analysis, show that analysis, and then there was a drop-down box where you could change the model you use to do that, and then your figure updated with model data from a different model run. Well, by the end of this, you'll have enough knowledge at least stored in the notebooks that you can go back to do something like that. So sharing notebooks. By using these Jupyter notebooks, you can actually take the file, because that's what these notebooks are, You can email them to someone, and then they could run your notebook on their machine and see the same stuff you're doing or that you've done. You could throw it up on Dropbox. You could FTP it if you wanted to. It's just a file. And the way you would do that is in your notebook, you got your toolbar up here where it says File, Edit, View, Cell, Kernel, Widgets, blah. We could say File, and then Download As, and it gives you some options. Do you want to give them the notebook so they can change it and do things to it? Would you like to send them an HTML version so they can see it all nice and pretty but not necessarily interact with it? You want a PDF version of it? We can do that. It's all good. You could also, if you have your notebook online, say on GitHub or at a web URL, you could use this thing called IPython, or the notebook viewer. And so let's see here. You guys have been to the workshop page, yeah? On these examples, if we go to, say, I'll give you a little taste from tomorrow. If I click on that link, it actually takes me to the notebook viewer site. And we can see we're going to be grabbing remote HER data and plotting it up. Oh, and soundings with it too. Hooray! And so this is all done through this service called Notebook Viewer, run by the Jupyter organization. And so you could send people, instead of an HTML file, they could just go to this website and see what you've done. Can't interact with it, but there's actually a service that will allow you to interact with notebooks that live somewhere else. Now, if you make these notebooks and you commit them up to GitHub, 404 not found. Yeah, that's okay. So this is our GitHub repository where we're holding all of our workshop stuff. So everything we're going to do is actually up on GitHub. And so I can go to Notebooks and Jupyter examples, sharing notebooks, and GitHub's smart enough to go, hey, this is an IPython or a Jupyter notebook. I can render that for you. And so there's our notebook all nice and pretty for people to look at if they wish.
Is there an easy way to track changes in the IPython notebooks with GitHub?
They're JSON. They're basically text files with the exception of the images. It's JSON. You know that. So largely notebooks are easily trackable with Git, other than the images. So the images are embedded pins. Git will still handle them. Your diffs just are nasty. But
right. So
we check all those into GitHub and then track changes that way.
So one thing you could do, if you're not interested in saving the images, but you just want to track the notebook itself. So here we've got a bunch of images, but really what I want is just the code that I've written and the markdown. You can go in the notebook to this thing called kernel and say restart and clear all the output.
Or if you don't want to restart the kernel, I think Cell has it.
Well, if you do restart and clear, if you restart the kernel and clear all the output, that gets rid of all the images and you just have your code. Now, of course, if you sent someone a link to the notebook viewer to view this, you wouldn't see any images there, and that'd be kind of a bummer. So just make sure you know the intended use for your notebook before you decide on a strategy for whether to keep images around or not. But certainly Git will work with these, and it loves them a lot. And to show you what a notebook looks like, actually, so here's the notebook that we were looking at with this sharing. If I look at the raw view of it, it is just JSON. And so that's got all the markdown and all that stuff in there. And if there was an image, you would see a big, it's just binary.
It's a base 64 encoded string.
Yeah.
So it's just a big blob of characters.
Yeah. Okay, so at the end of this, we have finally an example experimental notebook. Yeah, let's say we want to do an experiment within a notebook. So here we go. Are monotonically increasing integers really increasing monotonically? Hooray. So abstract, you have design, experiment 1. So basically what I'm going to do in experiment 1 is, and I'll translate this code for you. Basically we're saying make a range of numbers from 1 to 100 and plot them. So range gives you monotonically increasing numbers, and we have a straight line. So visually we can look at this and go, yes, monotonically increasing numbers increase monotonically. Hooray. Now that's not publication quality. You can't send that off. So you can pretty easily go through and add some labels and a title and a legend, change some things out, give the legend a little shadow behind it so it looks pretty. And then you could type up your conclusions and be done with it. Now, for those who are on the academic side, you could actually request that your students turn in their homework using a notebook. And that's a really good way to see, did you actually code this up and does your code actually run? I know from experience that I've gotten student code that will not run, but they put it in there saying this is the code I used. And if I would have had this back when I was teaching, I think I would have had my students turn in their notebooks. But your classroom, your dog and pony show, just a suggestion.
If you really want to go down that road, there are tools out there to help like create assignments as notebooks and handle the students submitting them back. If you really go down that road, yeah. It's called NB Grader. So there's a whole ecosystem of tools out there being developed that work with these notebooks for diffing them, converting them, running them without going through the web browser. So there's a lot out there in this space. We're just like hitting the tip of the iceberg.
Yeah. So this past section, like I said, right now you don't have to worry about understanding the code. This is more of an overview of what's possible by using these notebooks. And so
stupid question. So if you're on your own little laptop or something and you want to do a notebook, how do you pull it up with Jupyter? Does Jupyter notebook need? And what's the command to invoke it on your own system instead of on a website like you have?
You are running it on your own notebook. You are running it on your laptop.
Yep. Do you remember?
Okay, so it's always going to come up through web page.
Notebook is always the interface for the notebook is your web browser.
Okay.
Yep.
But
okay.
But you can also see there's a flip side to this. The potential exists that you could run a notebook server hosted somewhere and then remotely on your laptop access that server and have the same type of running code. You know, there's some security things you need to be careful in setting up, not letting anyone in the world execute arbitrary code on your system. But there is this power here of, yes, I'm doing things on my laptop, but I could put the server up there and let people, let me log in and execute code, put the server on top of a data collection so that you're running the code next to the data rather than downloading 200 gigs of data.
Yeah, we're quickly approaching the point of data becoming so big that bringing it back to your local machine to use is going to be not feasible. And so being able to do your analysis where the data lives, and in terms of transferring data back and forth, all you're doing is sending text to the server, and then the server might send you an image back. And so you're potentially talking about, oh my gosh,
orders of magnitude less data transfer.
Lots of, yeah, many orders of magnitudes less data transfer, but still having access to the raw data. Think GoesR or the GFS 8th degree that they're coming out with. I mean, we're living there on that edge of you're not pumping the data back anymore. Cool. Any questions?
Is there sort of a cheat sheet from MATLAB to Matplotlib?
that exists, we can look for that during lunch and
That would
get
be
them.
really useful.
People have put together those things for that reason. Yeah.
Yeah, there's kind of a general MATLAB to Python ecosystem. You do this command in MATLAB, this is kind of what you would do in Python.
And for NumPy, which we're in NumPy Matplotlib we'll talk about right after lunch, a lot of the functions are the same. The details come down to the syntax for working with arrays, because MATLAB is based on Fortran, so it's one-based indexing, and everything's a matrix, and things are matrix ordered or Fortran ordered,
Yeah.
the indexing order, whereas NumPy is zero-based, and things are just arrays, and it's C-based index order. But so there's little things like that, but otherwise the function calls like linspace, that's a MATLAB function, and most of them it'll translate very readily from MATLAB to Python. Any other questions before lunch? All right, so I know we did a lot of this has all been foundational stuff, so we're trying to lay this foundation. After lunch, it's going to be all Python all the time. So we start right off the bat. We'll be hitting 2 hours of NumPy Matplotlib and then NetCDF. So stick with us. We know it's not a lot of Python thus far, but it helps to get these tools built up, and then we're all from a common foundation. We can do even cooler stuff.
I
So
will lock this room during lunch too, so you can just leave the laptop in here if you want to.
we'll start up again at 1:15. Sound good? All right.